Slides are up, mic is working. Cool. Cool, yeah, so thanks everyone for coming, first of all. I think there's seats back there, some seats if you want to go. So yeah, we're going to present on DBT, which is, as mentioned, it's a data transformation framework, and it uses software engineering. It's a software engineering approach to the analytics workflow. And this is actually the first time we're talking about DBT to a software engineering audience. Like, we've mostly only talked to analytics audience. So hopefully this goes okay. So I guess maybe before we get started, like, how many of you have heard of DBT before this talk? Like, okay, not that many of you. Do you use regularly? It's fine. No, okay. No. Yeah. That's great. I think that's kind of the point of this talk, right? Is we want to introduce it to more people, and so it's actually kind of a good thing. So let's get started here. So who are we? So I'm Kshitij. I'm a senior software engineer at DBT Labs, which is the company that makes DBT. So both the open source DBT core library as well as the cloud version of it called DBT Cloud. And previously I was at Vouch Insurance, where I was using DBT, which kind of informs a lot of the talk. And with me today is Brandon.
Yeah, so I'm Brandon Segal, now senior analytics engineer at Spotify. Been there for about 2 years working with our data platform and ML platform to better understand how data is done at Spotify. But before this, I was actually a software engineer at Capital One. So really love DBT to bring some of those software engineering practices back into analytics.
Cool. So today's agenda is like 3 parts broadly. So the first part that I'll be giving is the intro to DBT, like what it is, why you should care about it, and how we're embracing software engineering best practices to empower analytics teams and make them as effective as shipping ultimately as software engineering teams using all the best practices that you know and love. Then Brandon will be presenting on a case study on Spotify, like how they use DBT as the nexus for their data ecosystem there. And then finally, I'll talk briefly about what's next for DBT, what's on the roadmap that's coming up. So multi-project workflows, Python SDK, and then probably leave enough time for questions at the end if you want to ask any questions of us. So cool, let's get into it. So intro to DBT. So DBT, as I've mentioned before, open source data transformation framework. So kind of think of, if you're familiar with ETL, it's the T in ETL. So let's rewind back. Let's start in 2015, right? So essentially, if you're an analyst, you have these 2 different workflows. Like, either you work at a megacorp and they have a data engineering team in-house that's like building these transformations, and they have a framework of their own, and that's how it's done, right? And then there's also like a smaller company, so you're downloading raw data from your SaaS tools like your Salesforce or your Zendesk or whatever the case may be, and you're doing data transformations in a spreadsheet. And so think of this as like your very, very simple, like filtering, cut by this metric, cut by this other metric, pivot tables, all that kind of stuff, right? That's kind of the 2 different things you're doing back in 2015. And I think this is like pretty accurate timeline wise, because like Airflow was like open source late 2014. So this tracks. So to borrow a quote from Tolstoy, each workflow is unhappy in its own way. At Megacorp, analysts are constantly blocked on productionization by the data engineering team, because the data engineering team, who is a software engineering team, are the only ones who can like really ship to prod. And so what the process is generally you have to file a ticket with them. They have to like read your SQL, convert it into like performance Spark, or Hadoop or whatever the framework they're using, and then kind of deploy it and monitor it. And essentially, they have an infinite backlog, right? And so how are you going to get prioritized on that backlog and on their roadmap? So that's the problem at Megacorp. At small company, essentially, you're doing a bunch of like really tedious and error-prone manual steps in Excel, and so a lot of it is like filtering the same data, but essentially you download a new CSV each time, then you're doing the same transformations on it again and again. And I mean, we're all human, right? Like you're going to miss something at some point, and it's not going to work. And so there's probably going to be there has to be a better way, right? And right now in this world, like analysts at both organizations believe kind of three things, right? So one is like analytics cannot be fun, right? It's something you just have to do, but you can never like enter a flow state like a software engineer would, where you're in kind of like perfect harmony. I'm sure most of you have felt this at some point with your tools, right? And you're never there. Analytics is like a purely reactive practice, right? So you cannot like do analytics to essentially identify the levers proactively for your business. So like the levers would be like, how many credits should we offer in order to get a new customer? Or like, do customers who open more support tickets churn more, or like stuff like that, like questions that businesses generally have, right? And because of these high upfront costs, you can only model what the current state of the business is. You can never kind of like explore what the state of the business could ever be. And then lastly, analytics is kind of like always seen as a stepping stone to something else, right? Like you're never doing analytics for its own sake, which kind of breaks my heart a little bit. And so since the promotion opportunities are limited, so the best people either like move to software engineering if they want to maximize their compensation, or they move into management, right? It's kind of like the two general paths people take. And so there's this like new technology on the horizon, the cloud data warehouse. You would have thought the solution was dbt, but it's not yet. We'll get there. So essentially there's a cloud data warehouse, which is this cool new technology that's come up. So it's fast. You don't need to wait for compute resources to become available the way you would on like a traditional like Hadoop cluster, right? You just like send a query, it runs, it returns you the results pretty instantly, because it scales up and down really, really quickly. It aligns incentives. You only pay for the resources you consume. So you're never, so essentially every analytics team now has like a profit and loss P&L statement, right? Like how much did you spend on infrastructure and like what insights did you deliver, versus like if you have shared infrastructure, it's often like really, really hard to detangle a lot of that. And lastly, it's familiar. Like your analysts are living day in, day out in SQL. And so they can send SQL to the data warehouse. They don't have to send like MapReduce jobs or Spark jobs or whatever else you're using there. And they can just vibe with it, I guess. And kind of like, so dbt builds on top of the cloud data warehouse. And it adds these new software engineering best practices to the workflow, right? And I think the three to highlight here are version control, CI/CD, testing, and then lastly, like documentation and lineage. So I think most of you are probably familiar with like the first two. The last one is like a bit unique to data, but I think you've also seen it before. So version control, right? You want to do a git diff on what has changed in your project, right? And essentially you want to say, okay, these are the things that have changed. These are the transformations that have changed. And so like I was testing out some feature, and so I changed 3 models and like what packages I've built, and it's showing up in Git. Great. So I have version control, and I have all the powers of version control. Basically, I can rewind back to a previous state. I can branch. I can do a number of things, right? You have CI/CD with that. This is a slide from my previous company where I was using dbt, where I was doing dbt build, like only building the parts that have changed, kind of like I guess like kind of like your more smarter like build systems like Bazel or something, SQL Fluff is a linter, and then kind of doing some like metadata checks with YAML check. And so you can do that now with DBT, right? Which is really powerful. So you have a lot of the same tools that software engineers have had for a long, long time. You have tests on your data. And so essentially you can run DBT test. It runs all the tests, and you can kind of see, like I'm running this on a local DuckDB kind of server, which is why it's like really fast. But you can run it on Snowflake or Redshift or BigQuery or whichever other adapters are supported in DBT, and it'll just work. We'll kind of look into what a test looks like a little bit later in the talk. And then documentation. I don't know if it's like big enough to read. It should be, yeah. So essentially, this is like the documentation for the customers table. It gives you the description of what the table is. A lot of times they're like practitioners' notes on like what this means. And the same for each column, right? You can see all the columns in the table, what its type is in your data warehouse, what a description is, and what tests are in it, and so on. And then of course you kind of have the next part, which is like reference by depends on, like what nodes depend on this model, what, and vice versa, right? And that kind of looks like this. This is lineage, right? And so like I created these three ones, like F orders 1, 2, and union, and essentially they're showing up now in my DAG, right? This is a DAG. So yeah, that's like a quick like whirlwind tour of like what DBT's features are. And so kind of what started happening over time is that a lot of these like loose technologies and like best practices started solidifying into a practice we now call analytics engineering. And the people who kind of like do this work are called analytics engineers, right? And I guess to steal Josh Will's definition of a data scientist, right? So I kind of think of it as an analytics engineer is someone who knows analytics better than a software engineer and software better than an analyst, right? It's kind of in the middle. And so they bring formal and rigorous software engineering practice to the effort of analyst data scientists, and kind of vice versa. They bring the analytical and business outcomes mindset to efforts of data engineering, and they build the tools and infrastructure to support the effort of analytics and data as a whole. And I think Brandon will talk a lot more about what that looks like in practice. All this is theory right now. So I think kind of the key takeaway, I guess, is like a lot of the analytics engineers are analysts who have kind of like moved upstream, and instead of working in the BI layer in your Tableau or your Looker or all these other tools, they're kind of like one level up now in DBT, and they're determining the data modeling layer, right? And I think this is kind of like where it's like sometimes a bit hard to explain where DBT falls, but I think like the way I think about it at least is this, which is like the spectrum between like ease of use versus power. And I think as software engineers, we kind of sometimes forget that our tools are very, very powerful, but at the same time, it's taken us a long time to like master them and be very good at them and use them effectively. And so let's like a lot of working with DBT is having empathy for the people who haven't sort of made those decisions, right? And so on one side, you kind of have like SQL, and on the other side, you have Python, and essentially power and ease of use kind of go almost in opposite directions, right? The more power you have, the harder it is to use a tool. And I think like DBT kind of sits nicely in the middle of the two, but quite a bit closer to SQL than Python. And by default, and I think I'll touch on this a bit later, but one of the superpowers of DBT is that it's declarative like SQL, whereas like Python, you have to be or a lot of other programming languages, you have to be very, very intentional to write declaratively, but most people by default will write imperative code. We'll kind of see how that plays out. And I think this is really, I've seen this time and time again. It's like, if you know SQL, you can pick up DBT in a week, which is like kind of insane in some ways. Like if you know SQL, you can write data pipelines in a week and ship them to prod. And that's really like what the power of DBT is. And I think kind of one sort of case study of this is like declarative code versus imperative code. So on the left is the DBT sort of like standard project called Jaffle Shop, and this is all SQL. And then on the right is the same thing, but with a library called Dagster that is a data pipelining tool. Kind of think of it as like Airflow++, and both are using like DBT as the DuckDB as the local database engine. But essentially, the code on the left is SQL and on the right is Python. But I think kind of look at these ones here, like the managers, like the DuckDB IO manager and the asset metadata, right? You kind of have to like import these into the Python version, but not necessarily the SQL version. And so like if you actually like scaffold it out, like the DBT code size remains the same, but essentially the Python code size has just exploded, and you've written a lot more like boilerplate code, right? Just in order to do the same transformations. And for a lot of things, this is actually like the right thing. Like, please do not try to do chat GPT and DBT. It will not go well. Use Python for that, right? But for a lot of like quantitative stuff, DBT is kind of often the right call. And then DBT kind of like takes that a step further. So you have declarative templating using Jinja. So this is, if you've like worked with web technologies, this should like, or any other technologies that use templating in some way, this should look like really, really familiar, where you have this loop and you're like scaffolding out these different like case statements. Yeah, this is like the simplest example I could find. You have other control flow structures like if else and other stuff too, but this is like declarative templating. And then I think what's kind of like unique is that you also have declarative testing, where you just say, this is how tests in DBT work, by the way, is you define in YAML what they should be. And so for on order ID, I have the test like unique and not null, because this is like the primary key. And so I want to make sure that it's always there and it's always like different. Status has to be one of these accepted values always. Like I cannot have like status like foobar, right? And then customer ID is like a foreign key relationship test, right? Like that this customer ID exists in this ref customer. So like in the customers table, and it maps to the field ID. So that's declarative testing. And then I think one thing that's like not required in DBT is DDL or DML, which is traditionally how you would do a lot of these transformations, which are like your alter table or like modify and all that stuff. And DBT does a lot of that, what we call like undifferentiated heavy lifting, to borrow a term from AWS, which is stuff that's like not critical to your business, what doesn't make your beer taste better, if you will, and kind of let DBT do that for you, right? And you focus on the business logic you want to ship to your end users. And then kind of the last thing I'll say before kind of handing off to Brandon here is that DBT is an ecosystem, right? So we have documentation, we have worked examples. I know this is like important for a lot of people. This is what actually got like convinced me to like try DBT, is that it had great docs. And they've gotten even better since I've started. There's like a team that does fantastic work there. There's like 65,000 plus Slack members. So if you ever have a question, even stuff like, how do I do X in like Snowflake, somebody will respond to you. A lot of times like the developer advocate from Snowflake is like hanging out there. And so he will personally respond to you, which is like really cool. There's a Q&A forum if you want to have like larger, sort of more open-ended kind of discussions. Of course, there's local meetups, so like find one near you. There's the annual sort of Coalesce conference, which I spoke at last year, which is where I borrowed the slide from, which was a lot of fun. You get to like meet all these people who are like really, really interested in DBT. And the last thing is like the open source contributors to DBT core, the open source library itself. There's like PRs coming in from people who use it, they want to propose a feature, or who are like on the beta versions, like we're shipping a beta right now, and they're like, hey, we found a bug in the beta. I think that's like incredibly cool that people take the time to do that. And of course, like package maintainers, right? So DBT has like a packaging system where you can essentially write these Jinja SQL macros, if you will, and ship them as packages. And there's a company called Fivetran, which is like more on the data ingestion side, and they have a team of 5 people that just write packages. That's their day job. And it's like really, really cool that the ecosystem is big enough to support that kind of effort from a major company. And of course, like DBT itself is an ecosystem, but this is like the broader data ecosystem, right? This is from A16Z. There's a lot of words in there. Don't worry about most of them. I think kind of like DBT hangs out here, like in data modeling land and like metrics layer land. So that's kind of like where it is. It's like transformation. So towards the end of the stack. So hopefully that maybe like puts things in context a bit for you. And then I guess kind of continuing on the ecosystem theme, like what does it look like in practice? And for that, I'll invite Brandon up to talk about the data ecosystem at Spotify.
Awesome. Thank you. So what we're going to be going over is just how DBT acts as a nexus for data at Spotify. A couple of the things that we're going to run through today are just what does data look like at Spotify? What is the ecosystem comprised of? And what are some of the core assumptions that we have? How did adoption of DBT happen from a grassroots efforts of a few analytics engineers to over 50 analytics engineers using it today? What are some of the jobs and toolings that show how DBT gets integrated with our larger data platform? And finally, just close out with what's next for the data platform at Spotify and how we see DBT kind of playing a role in that. So let's dive into the data ecosystem. So like the data space and DBT, data at Spotify is an ecosystem. There's hundreds of teams building data pipelines, producing data endpoints in BigQuery and GCS for consumption from multiple different personas, from ML researchers to data scientists, analytics engineers, and even user researchers and other people who may know SQL and or may just work with Scala and more conventional programming languages. A couple of our core assumptions is that data for insights, particularly, is a rapidly evolving problem. This challenge that we have is that data for insights constantly has to be adaptive to the larger business needs. Being able to adapt to those needs means that the best data sources and the most effective data teams are those that can empower those who work closest to the business to have that core effect on the data that's used for impacting those decisions. And a lot of times we don't want engineers to be the ones who are the bottleneck for that change to happen. We also believe that data for insights is a shared responsibility. When you have so many teams producing data, you have to make sure that teams are incentivized to take ownership and accountability for their data. This includes providing the right signals so that they can say that this data is meant for external consumption outside of their team, and that they have the tools to be good stewards of their data. And finally, we also believe that data for insights needs to be reproducible at scale. So for this, those that we believe should be working the most with the data, how do we give them the tools to be able to produce those clearly reproducible insights and have that reliable set of tools to do that. So another important piece is, what is a data scientist at Spotify? I could ask what's a data scientist, but that's a more existential question. But a data scientist at Spotify, the typical persona is somebody that wants to be able to tell compelling stories using data to affect the product strategy of the team that they work on. They're embedded inside of the teams. They are a partner with product. And we, as analytics engineers, work with them to build that ecosystem so that they can quickly deliver those insights reliably. So, I'm going to go through a brief history of what adoption of DBT looked like at Spotify. So, question might have come into your heads: why would Spotify adopt DBT? You guys have the engineers to build something similar. And in 2017, we built a Jinja tool with Python, templated SQL, and it was built on top of Luigi, Docker containers, and BigQuery. Basically, provided an interface so that analysts could be able to write SQL inside of files, get that workflow packaged up into a Docker container, and then when it runs on a schedule, it targets against BigQuery. Even included a unit testing framework that allowed them to pass in mock data to test out their complex SQL logic that was in there. And it fit a majority of use cases. It was biased towards immutable, writing immutable partitions of data, but that was the typical way of writing data for other Spotify pipelines. So 3 years later, DBT matures, and eventually we begin to see where the tool is falling short in terms of how it is able to deliver a delightful experience for our developers. So the development of the tool itself is constrained by internal resources. There's only so many people that we can allocate at Spotify to work on this one tool. Additionally, we did over-index on unit testing for these pipelines. A lot of the testing that's important for this kind of work is that integration with other systems and that other work that teams build outside of your team. So making sure that those assumptions still hold and that when they don't hold, somebody finds out about it through alerts and through the tests not passing before pushing to production. And also, with the limitations that the tool had, it limited how the teams could model their data. They were limited to certain materializations for their data. And this led to unoptimized pipelines. It led to cost inefficiencies, and it did lead to some inefficiencies in how teams were able to make changes to pipelines, including schema changes. So the adoption of DBT at Spotify was, I think, sparked in 2018 when the first AE role came about. The first AE was a senior data scientist who was this chimera of data science and data engineering skills. And they were like, you're not doing just data science, but you're not doing Scala pipelines and streaming. You're this cooler third thing. So they created the first AE role for them. And 2 years later, 8 more AEs had joined Spotify, and from their old jobs, they had brought in experience with DBT, and their evangelism of this tool actually led to the first kind of grassroots work in using it at Spotify. So with that building consensus over the past 3 years, there's been integrations built into our data platform to incorporate it better, to begin taking some of that pain and let the data scientists be able to contribute to these DBT projects that are coming all throughout Spotify. And now coming in 2023, we're doing work to incorporate it as a more official tool in our data platform, where the data platform teams can continue taking some of that work and helping build a more productive tool for these insights teams. So, where's DBT at Spotify today? Over 100 projects have been migrated to DBT from previous tools, and I think that is owed to the over 50 analytics engineers, and more if we count the people who are doing analytics engineering without the title, who are owning and building on top of these projects with their data science colleagues. And this is in part serving the over 1,000 Insights members who are at Spotify. So now we're going to kind of talk about what are some of the jobs that we expect these data scientists to do, that we expect everyone in Insights to be able to do, and where DBT fits in with that. So there's 4 main jobs. There's discovery, transformation, deployment, and maintenance. And discovery is that first job that comes about when you've answered the question of, what do I want to know? Or what do I want to add to what we currently have? And from there, you have to identify what is the right data, and if it does exist, does it have the right quality and fit the needs that my team has? Does it have the right SLAs? What tools do we use to define and deploy our data is that transformation step. This is kind of the part where teams have the most leeway. They can choose that, oh, I want my own compute. I'm going to spin up my own MapReduce job. I know that my data is already in the data warehouse, so maybe something using SQL is going to be the easiest to maintain for our teams. Then there's deployment. Deployment is how these changes make it to production. And in a room full of software engineers, we've always had things like linters, formatters, testing suites, and it seems silly to think that these insights pipelines shouldn't have the same things. And finally, there's maintenance. This is kind of that expectations that we have for data owners to be good stewards of their data and make sure that it is meeting the expectations that others have for that data. So we'll walk through a scenario. This is a scenario where our team wants to incorporate a dimension from another team's data endpoint. And we want to use that as a filter in our own metric. So part of discovery is we at Spotify have a window into all of our technology. We have a custom deployment of Backstage, which is our open source technology catalog. And in there we have our data discovery plugin. That data discovery plugin gives us an interface to search for data. We can search for it based off of the different quality programs that it meets, who's the owner of it, or what are some keywords or columns that we're looking for that we want to incorporate into our data. Once we found some good candidates, we can then dig deeper and see what is the source code? How was this data created? We can also look into the different quality programs that it meets, or even dig into lineage to see, is this the most upstream source of this data? And at which point should I use it? Once we've identified a new data source that we want to incorporate into our project, DBT makes it very, very easy to incorporate that data. So in this scenario, all of our data is already in the data warehouse. So it's just a matter of pointing DBT to say, this is where our source lives. And in there, we just define it through YAML. We have also tools at Spotify to help fill in additional metadata like column descriptions, column types, from the data warehouse metadata. And then once we define it, we can then incorporate it into our declarative SQL models. Here we're defining a staging layer, but once we've defined that staging layer, we can then declare different intermediate transforms of that data, and then finally incorporate it into our metric and our data marts. Once we're satisfied with how our change works locally, we've done all the changes, we've tested it locally, we can then open up a PR for our team to review. And opening up that PR then kicks off a series of checks. It checks off, okay, have you done the tests in a separate dev environment? And once in that dev environment, it will then run those changed models and see, okay, is there anything here in your changes that will break prod once deployed? It will then also do linting on the SQL code. And also, it will take those artifacts produced by DBT and try to create other additional artifacts for our other metadata services, like data endpoints, where it will then be incorporated into our data catalog without the developer having to write any additional configuration. Once we've gotten a approver to go through, review the code, and approve it, it will then run those checks again and deploy both that metadata and the workflows to our orchestrator, which is running in Flight, which is an open source orchestrator produced by the teams at Lyft. Once our changes are in production and we're running with them, we can then move to the process of how do we maintain this data going forward. Part of this is setting up our alerting. Our alerting is what we use to determine, is this data being delivered in a timely manner? Here we configure the different SLOs that should be expected from this data based off of its sources and what data we're using. And we can also use that to set up different PagerDuty alerts so that the insights team is alerted when those expectations are not met. And believe me, when the data scientists become on call for their data pipelines, these pipelines do get the attention that they need. The additional work is that we can also let our downstream consumers know when there is an issue because we have that data lineage that goes across projects to be able to say that, oh, there's an ongoing incident, here's how we're triaging it, this is how we ended up solving it, and having that cross communication and trust with our consumers. We also have monitoring. So monitoring of the workflows is very similar. We track to see if there's failures, missing dependencies, and we can go into these different workflow logs and the flight decks to be able to see at what point did these different DBT invocations fail, to be able to identify, okay, here are some places where we could create some optimizations, or we could triage what that issue could be coming from and doing that root cause analysis. And finally, a topic that's going to be very relevant to everybody in 2023 is costs. We use tagging at Spotify to be able to identify the data produced from these different DBT workflows and see how much are they costing us and be able to put a dollar number on the utility that those different data endpoints are providing us. If they are not providing as much utility as they should, that provides the incentive for the team to decommission those pipelines or modify them to reduce the regular costs of them. So that's Spotify as it is today. A quick look into what's next. We want to continue improving the data developer experience, and that includes those data developers who interface with data primarily with SQL. Empowering this group of users, we think, is going to be a huge, huge benefit to the productivity of Spotify Insights as a whole. So we want to begin leveling up the monitoring process for SQL. This includes providing custom metrics for teams to be able to instrument and profiling of their different data endpoints that they produce. Also tracking that lineage from the data endpoints to the different BI tools that that data ends up getting used in to track that impact that a change might have. We want to also be able to roll out changes to the data ecosystem as a whole. This entails making fleet-wide changes to DBT projects, to update DBT versions, update DBT packages, and that helps us be able to utilize the most up-to-date features of our DBT installation and implementation as we can, while safely giving that control to teams to implement it on their own teams. And finally, also providing that developer experience to tighten that inner loop of development, helping get teams onboarded onto DBT and in a productive space as quickly as possible by providing those environments to them so that they can take that entire that process of developing metrics, of developing insights, from discovery to deployment, all in one place. So I want to pass it back off to Kshitij, who can talk about what's next for DBT.
Yeah. So yeah, that's really cool to see what Spotify is doing. So thank you, Brandon. And before we dive into this next section, which will be pretty short, I know you guys want to get lunch. I do too. I think maybe I'll just spend a minute to point out that a lot of this actually happened here in Philadelphia. Like DBT was originally created as it started as Fishtown Analytics. It was a consulting company here. And Brandon is based out of here, which is why I invited him to give the talk with me. So a lot of like really cool stuff is happening here. So glad to be here with all of you. That out of the way, let's kind of like wrap up and talk what's next for DBT. Specifically what the analytics engineering workflow at scale should look like for everyone, right? Like what it should look like if you were my previous job, where I was like the only analyst. I didn't have like a huge team with the budget and the resources of a Spotify, right? And I think that's kind of what a lot of my new role at DBT is for, right? Is to build the tools for all those other teams who don't have maybe the time, resources, or energy to do so, and really, I guess, to innovate on their behalf. And so we put out a survey a little while back. You can go look at it. It's a great survey. And being a data company, all the data is available on GitHub if you do want to go look at it. So essentially, we asked what are the biggest problems still facing the modern data stacks. The modern data stack is like that huge A16Z diagram I showed you earlier of all the different tools. So kind of like what are the things that are lacking, right? And I think like the clearest one in the dark gray is like lack best practices for tooling. The top three are that one, lack data contracts, and cross-tool metadata sharing, right? We cannot really like do the best practices thing on our own, right? Like it takes a community. Like we at DBT Labs, we don't want to prescribe what a best practice is. We kind of want to work together with the community to figure out what that is and provide inputs where necessary. The other two, though, we can help with, which is like data contracts and cross-tool metadata sharing. So we'll kind of tackle those in reverse order. First data contracts, then the cross-tool metadata sharing. So what we're building right now, and my brilliant colleague Michelle is like leading this project, is multi-project deployments or data contracts. I guess maybe a good analogy here is think of it as like microservices, but for data. And so right now, like DBT is a huge monolith. It works best, like, or really only if you have like these huge projects. And so there are sometimes customers at DBT Labs who have like 37,000 models in their project, and that's like 37,000 files on disk, and it's like not really like scalable. And so what we want to do is essentially break these up into these different sub-projects that can then talk with each other, pretty similar to how microservices do. And so here we kind of have three different projects that we want to ship up. So the one in the top essentially is like finance, the middle one is like product, and then the last one is like e-commerce, let's say. And so what you want to do is you want to have like e-commerce have access to for sales data, right? Like Stripe transaction data from finance, but you don't want them to have access to like the employee compensation data, right? And this is like a pretty big concern at all companies. And so really we want to like provide a good experience where some data models can be locked down, so others can kind of and then others are free to use by other projects. And this right now, like there's workarounds to do this. None of them are super elegant. So like we kind of want to build this into the tool directly. So that's coming out soon. And then the next thing, which I'm tech leading, which is like it's in an even more infant state, is the Python SDK, right? So up until now, dbt has just been a CLI tool, and it's kind of crazy that people are using it in prod as just a CLI tool. But we essentially want to do better, right? And so we want to create these contracted interfaces for people to use from Python instead of just like either doing like an ugly like sub-process call from Python or like hacking into dbt internals, because in Python nothing's really internal anyway. So I guess the best way to sum it up is that the things people do with dbt both excite me and horrify me. And that is like the best way I can put it. And so we want to give them a better interface. And so here kind of we have this model that has these dependencies. You define what your dependencies are. Like I need dependency on model. Like I want to be materialized to the warehouse as a table, not a view, or these other things that these companies are coming up with. And then essentially you can override the run method. And so like a run right now does two things, which is like it takes your Jinja, compiles it to actual SQL, ships it to your data warehouse, and then returns back if there's an error. But maybe you want to like call some other endpoint, right? Like maybe the e-commerce site wants to run a certain model only if there's a flash sale going on. Otherwise, skip it, right? Or my canonical example is maybe you want to run some quantitative models only if it's sunny on Wall Street, right? So you kind of do that, then essentially you create this node. You have a dbt runner. Dbt runner is actually shipping in like a couple weeks. So like that part is real. This runner.insert and all that is not. But essentially then we want to allow you to like insert a node into the DAG and then run the whole DAG and get a status back. And then for each node from the status kind of iterate over those like you would any other object and kind of go from there. I'm sorry if this went over your heads a bit. But a lot of this is like for advanced users of dbt, and this is like kind of the use case we want to enable. It's like almost like the hidden levels of the video game, if you will. And I think the last thing that I'll say, and I'll close here, is it's still very early for dbt, right? And so one of the questions on the survey is, how long have you been using dbt? And if you kind of see the responses, like the majority have been using it for less than 2 years. And I think I would also fall in this camp. Like I've been using dbt for like 18 months at this point. And so think about kind of like your favorite framework and think about how long it's been around. And it's definitely a lot longer than this. And so I think there's like a lot of opportunity and chaos to determine what the best practices are for an entire industry and for this field. And I think that's what really like keeps me excited. And I hope that excites you about dbt too. And with that, that's it. Thank you.